start our patented Trail of Time talk. The Trail of Time refers to two things. One refers to the talk I'm going to give, and two, it refers to an actual trail that we're about to hike on. The 1.5 miles from here to El Tovar Lodge, the park has set up an interpretive trail where every, like 100 yards or so, there is a sample of every single rock layer in the Grand Canyon, in geological order from top of the canyon, from bottom of the canyon all the way to the top. Actually, I'm not sure which order we're doing it in right now. I think we're starting at the bottom, but it's gonna go through all those, and then you can compare it and contrast it with.
How many layers is that, Connor?
I don't know the exact number. You'll have to count for me when we go through it. So we'll go through all of those layers, and you'll get to see all the different rocks you saw and compare it with the pictures you took in the canyon. And then before we do so, I'm going to talk a little bit about the general story going on here. And the general story is that you are standing on top of the Grand Canyon, but you are also standing at the bottom of an ancient ocean, because this is all limestone. It's made of ancient sea life. It's made of calcium carbonate, the skeletons of ancient shellfish, bivalves, clams, mussels. Yeah, there are some trilobites and other layers in the canyon. And the rock itself, even if you don't see, like an obvious clam fossil, which there's one right there, the rock itself is made of diatom skeletons, the skeletons of algae and plankton floating around in the oceans. And then we're going to talk about how all of that from the bottom of the ocean came up here. Before we even get to that ocean, we have to go back to 1.8 billion years ago to the oldest rocks, which are in the bottom of the canyon. Do you see all of those you saw all the horizontal stripes down there. You'll see as we walk. But there's horizontal banding there. Vertical banding compared to the horizontal sediment layers. Those are ancient metamorphic rocks that have formed when a volcanic arc, very similar to the islands of Japan, a volcanic arc island collided with North America, and all of those rocks got mished and mashed. There's a lot of pressure involved, there's a lot of heat, there's a lot of time, it gets buried deep underground, and that changes the crystal structure of the rock. It gets cooked, essentially, and turns into metamorphic rock. And then we have, after the islands came, entire continents came and started colliding with North America, and like putty get all mushed and mashed around. You may have seen like wavy features. Did anyone see wavy features in some of the rocks down there? Yeah. That started as like purely horizontal rock that literally just got compressed and then became like that and gets mixed and mushed and all kinds of stuff. So that's the bottom of it. And then the next layer is actually hundreds of millions of years younger. We're missing several thousand feet of rock here at the Grand Canyon. The Grand Canyon today is 5,000 feet deep, but if all of the rock was here, like continuous, the Grand Canyon would be 3 times as deep, 15,000 feet. So we're missing 10,000 feet of rock that has eroded away and gone elsewhere. That's called the Great Unconformity, where the darker, kind of non-angular, is the way I'm going to say it, metamorphic rock in the bottom, it's not the nice horizontal layers, where that meets the first horizontal layers is the Great Unconformity. And then we get all the horizontal layers. Every horizontal layer is sedimentary rock, where mud, sand, limestone got deposited and built up, because this was all a shallow sea. And you can tell what kind of environment you're in and what kind of plants and animals might have lived there based on that rock. So for example, I think at the very bottom, some of that reddish rock looks like a mudstone, potentially. And a mudstone forms where there's mud. So we find mud in like river deltas, lake shores, probably not oceans, because that's where we find sand. So that tells us that that was a muddy environment. We can think of what kind of animals would live in marshes and the interfaces of like rivers with big bodies of water. That's mud. And then maybe the next layer up, things could have gotten even wetter. The water gets deeper. Maybe we get sandstone. Maybe we're in an ocean now. And we've got beaches and whatnot. And then we get sand deposited on top of that. That becomes sandstone, like the Navajo sandstone. Maybe we get even deeper. So now we're farther away from the beach and we're still in the same spot, but things keep getting deeper. So the beaches are moving away, water's getting higher. We're now in a deep ocean environment, and that leads to the creation of limestone as those animals die and settle to the bottom, create limestone. Maybe the next one, maybe the ocean's dried up and we have sandstone again. Maybe they dry up even further, and now we get mudstone again. So we have alternating layers of all of these aquatic or marine environments that slowly build up. There's also some dinosaurs that were walking around on those mudflats. So you can find dinosaur footprints as they walked along ancient lake shores down in the canyons. In some places, the wavy patterns formed in the stream beds. Like, have you ever seen a stream bed where you get those like nice little baby sand dunes and formed in like the mud creates those waves? There's fossil imprints of those you can see in the canyon, and the Trail of Time might have some of those as well. So we have ancient islands colliding with North America, ancient continents colliding with North America. Those get buried down, and then suddenly we have a deep ocean basin, and now we get all of those marine sediments on top. And then that also kind of gets buried. And later on, relatively recently, the whole thing starts lifting up, because remember, we're at 7,000 feet. So we're not really at like close to sea level or close to like basement level looking down into something. We're more standing on top of a mountain right now, looking down towards about like, what was it, 2,000, 3,000 feet at the bottom. Just about like the elevation of Phoenix or something. So you can kind of think of it as like we're on a mountain range that got cut into rather than we're standing somewhere where things. That cutting happened extremely recently, within the last 6 million years. That's how old the Grand Canyon is. Super recent. Thanks to the Colorado, thanks to freezing and thawing, as stuff up here freezes and thaws, it creates cracks. And then rain, snow melt, water just carries all of that sediment away. But it's really dry right now. The Colorado is kind of like a little pitiful, if you ask me. It's a very small river. So most of the carving that happened in the Grand Canyon happened during the last ice age, when this was much wetter. Imagine the bottom of the Grand Canyon being forested. That's how wet and cold things were during the last ice age. And so the rate of erosion and the rate of carving was much faster than it's kind of weird to think about how the Grand Canyon grows deeper at different rates in different climates depending on water and what's happening down there. Fun fact for you East Coasters, the Appalachian Mountains at one time were as big as the Himalayas. And then they started to erode, and all of that sand and all of those materials comes down into rivers and streams and gets deposited elsewhere in places like this. So a lot of the sediment in the Grand Canyon is made of the ancestral Appalachian Mountains, where all of that sediment came down the mountains, settled, and then made the rock here.
So cool.
Cool. So let's go
So cool.
explore the Trail of Time and see the different
Yay!
rocks.
Thanks, Connor.